Today we're covering lesson 7.5 and we're going to be talking about variation functions. And there's actually four that I'm going to cover with you to hopefully prepare you for the assignment that you'll be given. So quite a bit of information that I want to give you today. So let's just jump right in to the first variation function, and it is known as direct variation. And these pictures give you some graphical illustration of what direct variation is referring to. And basically what we're saying is, as a particular quantity increases, that causes another quantity to increase. So they both travel in the same direction. One quantity travels up and it forces another quantity to travel upward. And we could say that that's also true going in a negative direction. As one quantity or variable decreases, that forces a related quantity to also decrease. Very important that you nail down the equation, the general form of direct variation in equation form. And it always looks like this. It's very much what we've already looked at in terms of slope-intercept form. But direct variation will always take on this look. It will be y equals some number. We're used to calling it slope, but for direct variation it's known as the constant of variation, and it's identified as k. It is a constant, can't be zero. So y equals some number k times x. This, in equation form, represents direct variation. So let me just give you what direct variation is not. If you have anything being added or subtracted to k times x, okay, let's just give you an example. This is direct variation. Now it's not direct variation. So direct variation has to have a y-intercept of 0. Okay, if you see an equation that has something other than 0 being added or subtracted, 0 is being understood here, then this is not direct variation. Alright, it's a very basic linear equation. K is the constant of variation, and here's how we find it. We'll just use a little bit of algebra. It's very important that you can identify what K is just by solving for K. So if you take this equation, here's direct variation in equation form, and you've probably figured out that if I divide both sides of this equation by x, I will solve for k. So the way you can find this number called k, the constant of variation, is take the y variable and divide it by the x variable. Okay, so essentially we just took our original equation and divided both sides by x to isolate k. Alright, so the big takeaway so far, make sure you understand what direct variation looks like in equation form. Here it is. And then a related note, very important note, is how do you find this number called k? And you'll always find it for direct variation by doing y divided by x. It's always y over x. So let's just do a quick little real-life example. How does direct variation show up in our day-to-day life? Well, in our cafeteria, let's just take a lunch, for example. I think lunches are still $5 per student. So I can make a real simple direct variation function by saying that the amount of money that we collect, I'm going to call that y, is really dependent on the number of students that buy a lunch, and we're going to call that x. And the constant is the price of the lunch, and so we know that's, I believe, it's still $5 per student. So this y equals 5 times x is it's a direct variation equation or function, and it relates to our lunchroom revenue for the cafeteria. And k, of course, is that constant of variation. It's that number we sometimes identify as slope. K in this case would be 5. So you can see that truly we use the term varies directly. You'll see that a lot to indicate direct variation. Cafeteria revenue varies directly with the number of students. As the number of students go up, as far as buying a lunch, cafeteria revenue is going to go up. If that number of students goes down, cafeteria revenue goes down. So they work in a direct relationship based on this constant, which is the price per lunch, per student. Okay, so I just wanted to throw that out there so you can get an idea of what direct variation acts like in real life. And then you're not going to have to graph, so don't worry. But I did want you to look at what direct variation looks like when it's graphed. It's a linear function. So again, I've already mentioned that the y-intercept is always 0. So you can get an idea as the x quantity increases, that causes y to increase by whatever k is. In this green line, k is a half. Here you can see a little steeper line because the slope is now 3, or the constant variation is 3. So as x increases, y increases. As x decreases, y decreases by that constant multiplied called k. Alright, so let's just move right along. Now let's do some examples involving direct variation that you will see in your homework. So when you do problems 7 through 10, you're going to do this kind of activity involving direct variation. First of all, remember what it looks like in general equation form. That's very important. And then this is helpful just to help us identify what this number k is. They're not always just going to say, here is k. We're going to have to solve for it by using this little equation that I showed you in a previous slide. So let's just take a look at this example. We're told that y varies directly as x. Okay, so when I read that, right away I'm going to write this. As you see, it says varies directly, so I'm going to write this equation in general for direct variation. Okay, varies directly, pretty obvious. We're talking about direct variation, and that means we're using this equation form. Okay, y varies directly as x. So y will be on the left side, and varies directly as x means that x will be multiplied times k, just like it's set up here. And y is 15 when x is negative 5. Ultimately, we're supposed to find y when x is 7. So let me give you a really good clue here that will work when you're trying to work these problems on your own. Okay, first of all, very important that you understand what the equation looks like. We've already written it down. The reason for giving you both x and y, do you see how in one part of this sentence they tell me what x and y are, and then here they only tell me what x is? Well, here's a clue. When they tell you what x and y are equal to, that is so that you can find k. Alright, so the purpose for giving you both variables in the problem, underline just a little bit too much. Okay, so y is 15 when x is negative 5. That is telling me use this to find out what k is. Okay, now how do we find k? We divide y over x. Y divided by x. Okay, so let's take what we're told. Y is 15. X is negative 5. That means k is negative 3. Okay, now I'm going to take my general direct variation equation, and now I'm going to get a little more specific. I'm going to put negative 3 in for k. So if you like steps, step 1, I would just write down direct variation in general. Step 2, find k using the part of the problem that gives you both variables for x and y. Alright, and then you can write a specific direct variation equation that relates to this problem. Now I'm going to do step 3, which ultimately is find out what y is when we let x be 7. Well, that's going to be pretty easy, just taking our equation here, and we're going to replace x with 7 and do some simple multiplication, and we'll get y. So my final answer here is y is negative 21. Okay, so let me recap. Varies directly, that's phrasing that always tells us, pretty obvious, we're talking about direct variation. Pick out the equation for direct variation. Just write it down. Use the part of the problem that will give you the values for both x and y, and use those to help you find k. That will give you a specific direct variation equation that relates to your problem, and then you can use that equation to help you find your final answer. All right, let's try another one. Okay, so once again, get familiar with what direct variation looks like. Here's how we find k. This time they're using r and t, but that's hopefully that doesn't confuse you too much. I'll walk through this one with you. R varies directly, okay, keywords, talking about direct variation. R varies directly as t, okay, so R is going to be k times t. Okay, R is -20 when t is 4. Remember, the purpose of this, instead of just telling you what k is, they're going to make you work for it. So the reason for giving you the values for R and t, plug those in so that you can find out what k is. All right, R is -20 and t is 4. Okay, obviously this is 4k. Dividing by 4 on both sides, we got k is -5. Now, okay, I'm going to write a specific direct variation equation. Here it's just very general. Don't really know what k is. Now I know what k is. So let's get specific. R is going to be equal to -5 times t. Now that's going to help me answer the ultimate question of this problem. What is R if I let t be -6? Well, that's going to be pretty easy. I just drop -6 in for t, do the multiplication, and I get R is 30, and that is my final answer. Okay, very good. And you'll be doing that same thing on these 4 problems, 7 through 10. All right, number 2, let's talk about joint variation. With joint variation, it's similar to direct variation. It's just that now we're going to be involving 2 or more quantities being multiplied. So to fill in our blank here, one quantity varies directly as the product. Remember, product is just another way of saying the answer to multiplication. The product of 2 or more quantities. So on 12 through 15, you'll be doing problems that look like this. All right, so suppose y varies jointly. When you see those words, you know that you've got direct variation, but instead of just k times one variable, you're going to have k times 2 or more variables. So let me just take this phrase and translate it for you into an equation. Y varies jointly as x and z. Well, we're always multiplying by k when we vary jointly, and this time we're going to be multiplying k by these 2 different variables, x and z. So you see it's very similar to what we did before. It's just that now we're multiplying by 2 variables instead of just 1. Okay. The second sentence says find y when x is 9 and z is 2, but look at here. If y is 20 when z is 3 and x is 5. Do you notice how they gave you the values for y, x, and z? They gave you values for everything except for k, so that should be a clue. Much like we did over here, they gave you the values for r and t so that you could find k. Well, when they give you every value of variables except for k, that's your clue that this is what you're going to use to find k. Pretty obvious that finding k is very important to being able to find the answer, the final answer to our problem. Okay, so I'm not going to use the first phrase of this second sentence because this is telling me to find y given x and z, but if you notice in this next phrase I'm given the values of every variable except for k, and that's going to help me find k. So let's plug in 20 for y, k we don't know yet, z is 3, or x is 3, sorry. Let me back up, sorry about that. Z is 3, x is 5. X is 5, Z is 3. Okay, now we're good. All right, so let's multiply these together. I'll just come up here. 20 is equal to 15k. And we just go through the normal routine to solve for k. And we divide by 15 on both sides. And I'm going to reduce. And my final answer here is k is 4/3. Okay, now that's my answer for k. Now I started with a very general equation for joint variation. Well, now I'm going to get specific because now I know what k is. Y equals 4/3 times x and z. We'll just do it without parentheses. Okay, so again, write down your equation in general, then use the information in the problem to find k. Now write a specific equation that matches with this particular problem. And now we're ready to find y. You see how it's letting us, or it's telling us to find y given these values for x and z. So really all we have to do is substitute. X is 9, z is 2. We do some pretty simple math. This is 18 times 4, which is 72 divided by 3. And that simplifies to 24. So the final answer to this question, what is y when x is 9 and z is 2, will be 24. So I hope you followed that process. You'll use this same process every time you see the words varies jointly. It's just multiplication by 2 variables instead of 1. Okay, let's try another one of those. Alright, once again, y varies jointly, keywords. So what I normally do is just go ahead and write down the general form of joint variation. Y varies jointly as x and z. So that means I'm going to be multiplying k times x and z. The ultimate answer is going to be this. I need to find y when x is 9 and z is -3. But to do that, I've got to figure out what this number is for k. And that's going to come from this phrase. Notice how I'm given, I can't stress this enough, because a lot of people get confused. Well, how do I find k? Well, take the part of the problem where you're given everything but k. And that's this phrase that I've put brackets around. Y is -50 when z is 5 and x is -10. Okay, so I just took this part that I put brackets around, and notice I've plugged in everything except for k. And that should be a really good clue that that's going to help us find out what k is. Okay, so here we go, -50 times k, multiplied by -50 on both sides, and I got k is equal to 1. So now I'm going to write a specific joint variation. I don't really need the 1. I'll go ahead and put it. Oh. X, Z. Okay, we found out that k is 1, and now we're ready to find our final answer. What is y if we replace x with 9 and we replace z with -3? Okay, obviously it's multiplied by 1, x is 9, z is -3. We end up with our final answer, y is -27. Alright, so I hope that's enough to help you. You're going to be again doing this same type of thing on problems 12 through 15. So hopefully it helps. It's crucial that you find out what k is first, and then from there it should be pretty straightforward. Okay, we've talked about joint variation. We started off with direct variation. Now let's go to number 3, inverse variation. Well, as you can probably tell, it's really what you might consider the opposite of direct variation. Direct variation says as one quantity goes up, that forces another quantity up. Well, for inverse variation, as one quantity goes up, that forces another quantity to go down, or vice versa. as one quantity goes down, that forces another quantity to go up. And here you can see Batman has the thumbs up. One quantity is going up. The Fonz, who you may not even know who that is, the Fonz has the thumbs down. So as one quantity goes up, that forces another down. We would use the word or the phrase, they have an inverse relationship. They're going in opposite directions. Okay. Here's another equation that you need to be familiar with. You're going to use it a lot. This is inverse variation. And if you think about it, it makes sense. Direct variation meant multiplication, y equals k times x. Well, inverse variation is really the opposite, and the opposite of multiplication is division. So now we're going to do y equals k divided by x. All right? And the way we find k is just the opposite. For direct variation, we did y divided by x. And to find k for inverse variation, we multiply x and y together. Just think about how you would solve for k in this original equation. You would multiply both sides by x. Okay, obviously we cannot let x be 0, and there's no way that y will ever be 0 in this function. Here's some real life examples just to throw these out at you. Won't spend a whole lot of time, but if you're interested in where does this show up in real life, this is the kind of thing we're talking about, like economics. As the price of a good decreases, that causes an increase in demand. Just basic economics. So let's just move on since we got still more to cover. Here's the graph of inverse variation. That should look familiar to you because just before our winterim we covered lesson 7.3, which was the graph of inverse variation. And we looked at the fact that this creates a hyperbola. You're not going to have to graph in this lesson though, so I'm just going to keep going. Let's do some homework examples. So once again, in problems 17 through 20, they involve inverse variation. So notice how our equation looks. Notice how we find k. That's still very important. So let's do an example. A varies inversely. So as B, varies inversely as B. So right away, I'm just going to write down in general what that looks like. A varies inversely as B. K is always the numerator. And you can see how A and B have this inverse relationship. Okay, A is 28 when B is -2. That's helpful. I've been given the value of A and B so that I can find out what K is. All right, so just like we looked at with direct variation, we've got to find out what this value is so that we can find the final answer to this problem. So let's plug in 28 for A, -2 for B, and that's going to help us know exactly what K is. We multiply by -2 on both sides, and we get K is -56. So we can go from very general, just very generic, to specific. Okay, now I can turn this into A equals -56 divided by B. Start generic, find K, now get specific, and that's going to help you find the answer to this problem. Now let's find out what A is if we replace B with -10. Alright, so we do -56 divided by -10, and you can leave this in decimal form. It's going to be positive. A should be 5.6. Alright, so very similar process-wise, but very different equation for inverse variation. Notice the difference between inverse and direct. Direct always implies multiplication by K. Inverse always implies division into K. Alright, K will always be the numerator. Alright, let's try another one of those. Okay, if y varies inversely as x, alright, once again, I'm just going to write down in general what that looks like, and now I'm going to use the given information to find out the number that K needs to become. Y is -18 when x is 16. Okay, that's going to be helpful. Y is -18 when x is 16. So I need to multiply by both sides by 16. So you might want to grab your calculator for this. Negative 18 times 16, and that's negative 288 is k. Okay, so I went from very generic to very specific. Now I have an inverse variation function that matches what this problem is saying. And that's going to help me find out what x is, in this case, when y is 9. So notice a little different. This time I'm going to replace y and I'm going to solve for x. But not too bad. I'm just going to multiply both sides by x. And then I'll divide both sides by 9. So you might want to grab your calculator again. Negative 288 divided by 9. And that's negative 32. So just pay close attention to what the problem is asking for. And once you get your equation or function written, then it's just a matter of doing substitution and basic algebra. Okay, so far so good. 3 down, 1 to go. Let's talk about combined variation, and the name pretty much gives it away. We're talking in combined variation a combination of direct and inverse. And I'm going to show you how to set these up. Both of them occurring, direct and inverse variation occurring in the same function. And I've given you problems here, a heads up on these 4 problems that will work a lot like what we're about to do. Okay, so let's just work our way through this, turning these words into an equation. Suppose f varies directly as g. All right, let's just take that part. We know what direct variation looks like. We've been practicing that. F varies directly as g, so that's going to be k times g. Direct variation always means multiplication by k. And f and g are in this direct variation relationship. Okay, let's read on. F also varies inversely as h. Well, inverse variation always means division. K is always the numerator, so all I'm going to do is take what I wrote for the direct variation part and I'm going to divide by h. And so we have the combination. We have the direct variation multiplying by k, and we have the inverse variation dividing into k. Okay, now let's keep on reading. Find g when f is 18 and h is negative 3. But this is the key to our next step. Do you notice in this phrase they give us everything but k? I can't stress that enough. Go to the part of the problem where all of the variables are given except for k, because that's going to help you find out what k is. And knowing what k is the key to unlocking the answer to this problem. So let's plug in everything we know. G is 24, h is 2, and f is 6. Alright, so we've replaced everything in our function except for k. And now we're going to solve for k. Alright, I'm going to multiply by 2 on both sides. I'm going to divide by 24 on both sides, and that gives me k is 1/2. Alright, just like we've done before, I started off very general. Now that I've found k, I'm going to get specific. I'm going to write an equation that relates to this particular problem. F is equal to, I'll just say 0.5, or if you want to do 1/2 g over h. Okay, and we can just leave it like that for now because our final answer is going to be just a regular number. Alright, so make sure you understand how we found k. We've got this function, it's really a combined variation function, and now we're ready to come up with the answer for g. Let's find out what g is if we replace f with 18 and we replace h with negative 3. Alright, so taking what we just wrote, I'll just come over here. I'm going to let f become 18, and I'm going to let h become negative 3. Okay, I'm going to multiply both sides of this by negative 3. I get negative 54 is equal to 1/2 g, and then it's pretty obvious how I solve for g. I just multiply by 2 on both sides, and I get negative 108 is my answer, my final answer for g. Okay, so once again, it's imperative that you find k, write the equation with that new number that you found for k, and then it's just a matter of substituting and using algebra to find your whichever variable they ask you to find. Okay, one more of these and we are done with your notes. You're ready to start practicing. Suppose A varies directly as B. Alright, that's direct variation. So A, should go to a different color. A varies directly as B. That's what that means, multiplying by K. And A varies inversely as C. Well, inverse variation again means division, and in this case we're dividing by C. Okay, the final answer they want to know what B is if A is 8 and C is negative 3, but to me this is the most important part of this problem, because giving me B, C, and A values to plug in for those will help me know what K is. And if I don't know what K is, I can't get to the answer. Alright, so B is 16, C is 2, A is 4. Oh, sorry about that. C is 2. I was looking at that one. Okay, double check that. B is 16, C is 2, A is 4. Solve for K. Alright, multiply by 2 on both sides. Divide by 16 on both sides. And we got K is the same as what it was in the previous problem. So I'm going to write this using 1/2 plugged in for K. And now I'm ready to find the final answer, which they want to know what is B if you replace in your function, if you let A be replaced with 8 and C be replaced with negative 3. Alright, multiply by negative 3 on both sides. Negative 24 is 1/2 B. Multiply by 2 on both sides. B is negative 48. And we have our final answer. Okay, a lot there, and I hope if you have questions you'll go back and rewatch these. I hope you took thorough notes. These are the problems that you'll be working on in the assignment, and I will be posting a homework help video. I'll select certain ones of these, and I'll take your questions on Tuesday. Work hard on it, and I'll see you Tuesday.